Great, thanks. Okay, thanks, Matt. Thanks, Kurt. Jesse and I both really appreciate the opportunity to be able to speak to you all today. We would have preferred to have been in your neck of the woods instead of the unrelenting hailstorms we've been getting for the past 2.5 days. So, yeah, but hey, technology, we're glad to be able to join you. So, yeah, so Jesse and I are collaborating on giving you all a presentation on just some of the ways that we here at NOAA's National Centers for Environmental Information are working to improve the discovery and access of our bathymetric data holdings through our geospatial web services. So next slide, Jesse. Great. So just a slide or two, in case you're wondering what the heck is NCEI. So our National Centers for Environmental Information, and there are a few offices around the country. We're out here in Boulder, Colorado, but we also have an office in Asheville, North Carolina, down at Stennis in Mississippi, and in Silver Spring, Maryland. So we are responsible for hosting and providing access to really the largest archives of atmospheric, coastal, geophysical, and oceanic data collected in the whole world. And so here in Boulder, we really focus on the geophysical aspect or piece of that. And so as such, we are the nation's leading authority for environmental information. And so we preach all the time that it really is through the proper stewardship of ocean and coastal mapping data that will ultimately maximize its use and reuse. Next slide. So again, we are the stewards of these environmental information, just a pretty little mosaic of some of the sampled data sets. The big bosses like to say that with data that spans from the Stone Age to the space age and from the depths of the ocean to the sun and across the globe. Next slide. But today, since we just have 20 minutes to speak to you all, Jesse and I decided we really wanted to focus in just on one of our data sets. And this is one that takes up most of my day every day, and that is bathymetric data. So data, echo sounder data of the shape and depths of our seafloor. And the reason we're focusing on this is that we've been putting forth a tremendous amount of effort on improving our discovery and access systems, because there are two major seafloor mapping campaigns that are taking place throughout, really focusing on this decade. So one is known as the Seabed 2030 project. This is a global effort to map the world's ocean floor and to produce the definitive grid of our seafloor. We have our work cut out for us, since the data gaps are what you see there in black. We are currently at 24.9% of our ocean floor mapped to modern standards. That number just came out last week. That's why I have it at my fingertips. So we do serve as the archive for these data, and we spend a lot of time collaborating with the global community on, again, how to improve discovery and access of these data specifically for this project. And next slide. At the same time, we're also doing a very similar effort here in our own backyard. This is known as the NOMEC effort, the National Strategy for Ocean Mapping, Exploring, and Characterizing our U.S. Exclusive Economic Zone. So out to that 200 nautical mile limit. So again, you look at the red that you see before you, and that is the data gaps. So the U.S. doing better than the global average, but not too terribly much. We're still clocking in at around 50% of unmapped waters, just even here. So again, this is mostly being driven by federal agencies here in the US, definitely academia and industry as well, but we are, again, that primary archive for these data. So we have a lot of folks telling us what they would like to see. And that next slide is when I turn to Jesse and ask him to try. Oh, actually, I do have a few more slides, but that is when I turn to Jesse to see if he can make these requirements a reality. But discovery and accessibility, that really is what it's all about. I mean, the public value of data and products, and not just bathymetry, but all of these data types, really does become maximized. Obviously, if we can streamline that data acquisition and processing, we can all agree to use common standards, promote that reuse, and then again, really focus on that discovery and access piece. Next slide. So we do here at NCEI draw on a variety of software technologies that really do attempt to adhere to the recognized data standards that are out there. And so the result is, of course, this geospatial framework that's built on top of those standards-based geospatial services, applications, spatially enabled databases, and ISO metadata. Next slide. And with that, I will hand the mic to Jesse. So Jesse, I think you did lose your screen share there. There you go.
Yeah, I got it. Yeah.
Okay, perfect. And Jesse will go into the details of some of the work that we're doing. Thanks.
All right, thanks, Jen. Yeah, just a quick overview of what I'm going to talk about here. I'm just going to go over a little bit of what GIS web services are and a set of examples of those. And then I'm going to do a live demo of our Bathymetric data viewer. And then I'm going to talk about how we're modernizing some of these map viewers and give another demo of one of these new map viewers called the NOAA Ocean Exploration Data Atlas. So yeah, GIS web services are kind of like the building blocks for putting together all these web applications. They provide data discovery, access, and visualization. We have a bunch of these services either published through ArcGIS Server or ArcGIS Online services as well. Different types of services include map services, feature services, image services, and different types of tiled services. And many of these do have OGC standard endpoints as well, which we're trying to make sure is enabled on most of these services so that they can be used in non-Esri environments as well. So I'm going to go into a little bit of detail on our image services, which is a big way that we're publishing and visualizing bathymetric data. So these image services are published through ArcGIS Server, and they can provide either actual data values, like either integer or floating point, or they can provide imagery, such as these RGB color hillshade visualizations. Yeah, these services are kind of reusable in many different places. We're organizing the data in ArcGIS mosaic data sets. So general layout of this is you have a bunch of source rasters, which might be overlapping in different resolutions. You load those into a mosaic data set, which is kind of like a big table. And then you use that mosaic data set to also generate overviews, which really speeds up the drawing of the mosaic when you're looking at different scales. And then you publish this mosaic data set via ArcGIS Server to produce an image service. And just some example outputs are here. An example of the way we're doing this visualization is we're implemented this using ArcGIS raster functions. So just one example of one of these raster function chains. I'm rendering it as I'm rendering the bathymetry kind of just using a color map, and I'm also rendering it using a hillshade, and then those images get combined together using this pan sharpening tool, and then it gets, and the output creates this color hillshade visualization. So that's kind of a server-side visualization that can be toggled on these image services, which is pretty cool. So some work I'm actually doing right now is working to improve the color ramps that we're using for these bathymetry maps. There's been some progress recently on like creating more scientifically accurate color ramps that are perceptually uniform, logically ordered, and also friendly for users with color vision deficiency. And you can find out more information on this website here, which has a bunch of example color maps. So I've applied that to some of our services here, and we're going to be rolling this out pretty soon. And another challenge is kind of showing the details in the shallow water, while also having it be stretched for the entire depth of the ocean as well. So that's kind of been a challenge, like to get these color stops, these depth areas stretched properly. So after we generate these hillshades, so sometimes we also export a big tile package and then upload that to ArcGIS Online to create a hosted tile layer. So some examples of these image services are, here's the multi-beam bathymetry mosaic, which is about over 3,500 surveys all combined into one mosaic, covering the whole ocean. Another example are these DEM mosaics. There's the DEM global mosaic, which is a composite of a bunch of individual DEMs. And there's also this project called the continuously updated DEM, which is good, really nice coverage for the US coastline, which is at 1/9 arcsecond resolution near the coast and 1/3 arcsecond resolution as you go further out. We also host some mosaics from that were collected by the NOAA ship Okeanos Explorer. So these are some bathymetric grids from that team. We're also using those for like doing 3D visualization. And I'll show a demo of this in a minute, but we're also, when the ship is at sea, we're receiving grids like as they're doing the mapping and creating these kind of daily updated grids while they're out at sea, which is pretty cool. This is called there's another product called the US Bathy Gap Analysis, which is basically taking all public data and classifying it into either not mapped, minimally mapped, or well mapped. It's kind of these different categories. So just kind of taking the sounding density and classifying it into these two main categories here. So this kind of tells you at a glance like what's been mapped and what hasn't been mapped in US waters particularly. There's also another mosaic that is for NOAA hydrographic survey data, which is a lot of really high res data near the US coast, kind of usually going up into harbors and bays and stuff. So this is called the BAG mosaic, and BAG is abbreviation for the Bathymetric Attributed Grids, which is a file format that is used for archive. So with that, I'm going to do a quick demo of our bathymetric data viewer, which is right here. So this is what you see when you go to the viewer. You can all these green track lines are the ship tracks of multi-beam bathymetric surveys in our archive. It's loading. And you can start to do some filtering here. Like say I wanted to only search for a certain ship platform name, like the Kilo Moana. You can just filter based on that, and it'll just give you that subset of surveys. And then you can like draw a box and identify the data in your area of interest. So there were 19 surveys in that area. And then you can click this to go say extract data, which will go to another site that'll allow you to put in your email, and it'll package up the data for you and then send it. Or you can click through on each of these and to learn more about them. You can link to another website that is kind of like the landing page for that survey, where there's metadata, and you can download files from here as well. And you can also get access to these mosaics I was just talking about. So here's the multi-beam bathymetry mosaic. So pretty cool coverage for the whole world here. And then there's the NOAA hydrographic survey data, like the BAG mosaic that I was just talking about. Looks like this. And you can zoom way into a coastal area and see those details, and also see the let's do a reset there. can see the outlines of those surveys as well. And each one of these hydrographic surveys also has a landing page. So here's where you can download the files and get metadata and so forth. And then there's the DEMs. Here's the DEM shaded relief. So this is called the DEM mosaic. This is the CUDEM, or the continuously updated DEM. I'm going to zoom over to the East Coast where there's better coverage. So this is the CUDEM for US East Coast, along with the footprints in orange. And this is pretty good. You can zoom way in and see some details here. So I think that's it for the demo on this map viewer. Let's see. So this was that viewer I was just showing off is kind of what we consider one of our legacy map viewers, which are using ArcGIS API for JavaScript 3.x and Dojo, and mostly relying on on-prem ArcGIS server map services. But we're currently having an effort to modernize a lot of our map viewers, which will help us with maintainability and also updating to the latest ArcGIS JavaScript API, and also just more modern UI design, and also going to help us with 508 compliance and accessibility. And we're also, another thing we're using a lot more and more is ArcGIS Online, which is also known as NOAA GeoPlatform, which is NOAA's version of ArcGIS Online for organizations. And there's a lot of different things we can do there, like hosting various layers, hosting feature layers and tile layers, as well as doing things like story maps and different web apps. There's also something called Experience Builder, which some people are using to build their web apps. And it's a really useful tool to have. So our new map viewers are, some of them are brand new apps and we're rewrites of existing map viewers using the latest JavaScript API. And we're implementing these in JavaScript with React and Material UI and using TypeScript as well. And this is an example of one of these new map viewers, the NOAA Ocean Exploration Data Atlas. I'm going to give a quick demo of that as well. So here's the data atlas. So first of all, you can see this is the current position of the NOAA ship Okeanos Explorer right here. A few days ago, they left from Seattle and they've been sailing across here and they're heading to the Aleutian Islands right now to do some multi-beam mapping. So that's the current live position of the ship here. And you can see some of the recent bathymetry collected by the ship as well. So they've been mapping this swath here, crossing some seamounts, and so you can see some nice, cool new data right there. It's brand new data. So this map viewer is a way of exploring data that's sponsored by the NOAA Ocean Exploration, which is we have a partnership with NCEI to host. We host data collected by NOAA Ocean Exploration, and so these are locations of all the cruises funded by that program, and you can scroll through this list and see a bunch of cruises and explore the data. So you can use this thing on the right here to explore. Like, say I was interested in this cruise EX2104. So show one map, and it'll zoom to it, and then you can see there were 20 ROV dives associated with that cruise, and you can click through and actually see the dives that they did, where they sent an ROV down to the seafloor and collected samples along the way, and you can see the positions of these geologic and biological samples and the track of the ROV. So you can zoom into the different ROV dives here. Another way of visualizing those ROV dives is using this 3D scene viewer here. So each one of these yellow dots is an ROV dive. And if I were to zoom in here, you can actually see that they're in 3D. So there's an example of a 3D ROV dive draped on top of actual bathymetry. And you can see that the ROV entered the water here and then descended to the seafloor and then did some work on the bottom here and then went off bottom and rose back up to the ship here. So it's just a cool way of visualizing it. I think that's probably about it for my demo here. I had a bunch of backup slides here I'll skip through. So things we're going to be working on in the near future are just continuing to improve these services. We're going to be transitioning more of these services into ArcGIS Online or the NOAA Geo platform. And then we're going to be continuing to modernize these map viewers. And one example is the Bathymetric data viewer. We'll end up rewriting that at some point, probably next year. So takeaways from this presentation, NCEI is committed to providing easy and open access to all public data built on these geospatial services to enable data discovery. Discovery enables reuse of the data, and reuse of the data increases its value. So you can learn more about a lot of our services on this link. This is kind of a homepage for maps and geospatial products. And I think that's it. Thank you very much. And I think it might be time for some questions.
Okay, now I think you can hear us again. We clap for you. Yes, we're clapping again. Thank you so much, Jennifer and Jesse. That's a great presentation. Any questions from here? And can you hear us? Just to double check. Great.
Yeah, I can hear you up there. We'll have to see if we can hear people in the audience. So
yeah, I'll try to repeat the questions as we get them. Anybody have a question?
There is one on the chat.
Hold on, we're checking the chat here too. I have a question too while we're checking the chat. Can either of you speak to, I know there's, like we have members, employees from Monterey here. I work for NOAA Fisheries Service. I know there is a pipeline for submitting data to NCEI, particularly bathymetric data. Can you talk a little bit about how that process works?
Yes. So for all of the UNOLS fleet, that data is in an automatic pipeline called the rolling dector repository. So any data collected on a UNOLS vessel makes its way to Lamont, and then that data comes into us pretty much on a weekly basis. Kind of oddballs that fall outside of that, it's really just about reaching out to us and getting a data submission agreement established and getting that data in. But with the NOMAC effort that's going on, there's been a really big push to be going out to as many partners as possible and trying to dust that data off the shelves and
Sure.
get it included to the national effort.
Okay, great, thanks. Yeah, and we had one question from the chat from Jenna. Thank you, this was fantastic. Can you toggle off the vessel path tracks, I guess? And I assume Jenna's referring to that most recent demo that you gave, Jesse.
Yeah, there's control.
The original Bathymetric.
Yeah, there's controls like hidden in a widget, like it's called a layer list, and you can toggle things on and off there. And that's another, that layer list widget is where you can view information about each layer as well. You can go off and link to the ArcGIS Online item pages for those and learn more about them.
Great. Any other questions, Steve? Yeah.
So I get a little confused. I download multi-beam data frequently, and I know I use MGDS to download, I think, the raw multi-beam data. Are you guys sharing the raw data, or are you just sharing grids?
We
So
are,
yep.
got that. For the most part, we actually archive the raw unprocessed bathymetric data. So we also work closely with MGDS, and we have a plan to start bringing in their processed data as well. But raw bathymetric data is our highest priority. And then with that multi-beam mosaic that Jesse was showing off, that is a mosaic of that raw data, so not cleaned, so not to be confused with like what GMRT is at Lamont. But we do have like an auto gridding capability or grid extract capability that you can also go in, draw your AOI over a piece of the mosaic and download that as well as the GeoTF. But short answer, we mostly archive and make available unprocessed data.
Can I just follow up? Sure. Like, how do the two databases compare as far as, are you importing their data? Are they importing your data? Who's more up to date? What's the difference between the two?
So Lamont imports all of our raw unprocessed data, and they are funded by NSF to clean that data and to make the GMRT grid. What also goes into the GMRT grid or product are products of varying resolution. So that goes to them and typically does not come to us.
Any other questions? All right, thanks, Jennifer and Jesse.